Good morning, students. Now we have explained the preparations and the classification of the amines. Now today my topic for discussion is chemical properties of the amine after the exhaustive discussion of physical properties and methods of preparation of the amines. Right. So we take today chemical reactions, chemical properties of amines. So various important chemical reactions of the amines are, first is the acylation. Acylation takes place with the help of acetyl chloride or acetic anhydride. Products will remain same. See, if you take CH3NH2, it is the 1 degree amine, is made to react with Cl C double bond OCH3. This is acetyl chloride or ethanoyl chloride. Right. This H or this Cl is lost here. HCl, CH3NH, C double bond OCH3, N-methyl ethanamide. It is made to react with alkali and it is very much soluble in water. OH plus H, water is lost and it forms N sodium or potassium, N-methyl N-sodium acetamide or ethanamide. This is for 1 degree reaction. Now come for 2 degree reaction. NH, it is dimethylamine, Cl C double bond OCH3, HCl, CH3 and C double bond OCH3. Whenever dissolved in alkali, then it is, what is that? Very much insoluble. The nomenclature is N-dimethyl ethanamide. N, N, dimethyl, this is the ethanamide or N-dimethyl acetamide, right? Next we take the 3 degree amines, CH3, 3 times, it is 3 degree amine plus ethanoyl chloride. Now I write here no reaction. It will not react because of tertiary amine does not contain any active hydrogen atom. So the way we can distinguish primary, secondary and tertiary amine by taking acetyl chloride or acetic anhydrides, the product will remain same. If this reaction takes place with help of benzoyl chloride, so that is known as benzylation, right? Then the next is the benzylation. You take the primary amine, this is the CH3 NH2, Cl, C double bond O and benzene ring. It is known as benzoyl chloride. So here this one H and this one Cl is lost here. It is 1 degree amine. So that is what it is, the HCl lost. CH3 NH, C double bond O and this is the benzene ring. N-methyl benzamide, N-methyl and benzamide, which is further soluble in alkali. NaOH or KOH, it is very much soluble like previous reactions. If you take 2 degree amines, simply I take H5COCl, then it is, what is that actually? Now HCl is lost here, CH3 whole twice N, C double bond O, C6H5. And in dimethyl benzamide, N comma N, dimethyl benzamide. You take the tertiary amine, and again you have placed benzoyl chloride. Further you write no reaction. So acylation or benzylation, only you have to change the attacking reagent. In case of the acylation, you take acetyl chloride, or in case of benzylation, you take benzoyl chloride. Now the next chemical reaction is Hoffman's carbyl amine reaction, or you can say carbyl amine reaction. It helps to distinguish, between 1 degree and 2 degree amine. Now primary amine, whenever made to react with, when 1 degree amine made to react with chloroform and alcoholic KOH to form carbyl amine with foul smell, unpleasant, offensive smell or foul smell, which confirms the presence of primary amine. If I take RAR, NH2 plus chloroform plus alcoholic KOH, then it gives RAR, N double bond and coordinate bond C. It is carbylamine or isocyanide or isonitrile. Now I take, either it can be aliphatic or aromatic. I take for example methylamine. It is 1 degree amine, plus I take chloroform CH, Cl, Cl and Cl plus KOH, alcoholic 3 times potassium, right, 3K and 3 chlorines are lost, minus 3K Cl, hydrogen and hydrogen and hydrogen. That means 3 water molecules are lost. Then CH3 and double bond and coordinate bond C. What is the nomenclature of this compound? Yes, the nomenclature is methyl. It is the methyl. So it is methyl isocyanide, or you can say methyl carbyl amine, or you can say methyl isonitrile with foul smell. Right, this is the recognition of primary amine. In case of aliphatic, we just take aromatic amines. You take here C6H5 NH2, this is the aniline, or benzenamine, or phenylamine, or aminobenzene. Now chloroform CHCl3 plus 3 times KOH alcoholic. Now 3KCl minus 3 times water, and it forms like phenyl isocyanide or phenyl carbyl amine, foul smell. But in case of 2 degree amine, it will not react because of, in case of the 2 degree amine RRNH, it is 2 degree, but there is no reaction because water cannot be removed. And I take chloroform plus KOH alcoholic, then you write further no reaction because of water cannot be balanced. As such, this reaction makes a difference between 1 degree and 2 degree amine. It is carbyl amine reaction. Now next is the You can see Hinsberg reagent test. Hinsberg reagent test. Now, what's the formula of the Hinsberg reagent? This is very, very important reagent. Benzene sulfonyl chloride. It is called as benzene sulfonyl, and what is that? Chloride. You take primary amine CS3NH2 plus benzene sulfonyl chloride like this, C6H5, this H or this Cl lost here, HCl, CH3NH SO2 and C6H5, N-methyl, what the nomenclature? Yes, N-methyl benzene sulfonamide, N-methyl benzene sulfonamide. It is whenever made it alkali, it is soluble, right? In case of the 2 degree amine, CS3 whole twice NH, it is secondary amine plus Hinsberg reagent. This H and this Cl is lost here. So HCl is lost. It is 2 degree amine. I mean dimethylamide. So CS3 whole twice N SO2 and C6H5. Whenever it is dissolved in alkali, you write no reaction because of H is not there. So it is called N dimethyl N comma N. It is the dimethyl benzene sulfonamide. So far as 3 degree amine is concerned, 3 degree amine, trialkyl amine, no hydrogen, plus Cl SO2 C6H5. You write here no reaction. So the way you can have the distinction between 1 degree, 2 degree and 3 degree amine by taking Hinsberg reagent test. Hinsberg reagent is benzene sulfonyl chloride C6H5 SO2 Cl. Next is the nitrous acid test. Next is the nitrous acid test. It is prepared in C2 with NaNO2 plus dilute HCl, that gives HNO2 plus NaCl at 0 degrees Celsius to 5 degrees Celsius. So it is the nitrous acid test. In case of the primary amine, this is CS3 NH2 plus nitrous acid. This H, this oxygen, water is lost, nitrogen or nitrogen, N2 is lost, CS3OH. It is called as, what is that? Methanol. You take aromatic amine, no, aniline. Aniline is diazotization, NaNO2 with HCl at 0 degree to 5 degrees Celsius. This reaction is actually called as diazotization reaction. So here, dear students, benzene diazonium chloride is formed. Whenever it is boiled with water, then you remember minus N2 minus HCl, phenol or carbolic acid is obtained. So this is for aliphatic as well as aromatic by taking nitrous acid. You take 2 degree amine, it is secondary amine, and then nitrous acid, OH and H. Water is lost, NN dimethyl nitrosoamine, NN N comma N dimethyl nitrosoamine. Now in case of 3 degree, plus nitrous acid. Now this time it will give salt, CS3 whole thrice, NH positive and nitrite negative. Trimethyl ammonium nitrite. Trimethyl ammonium nitrite. These are the important chemical reactions of aliphatic as well as aromatic primary amines. Now, electrophilic substitution reaction of aniline. As you know, aniline has positive mesomeric or resonating effects. We have already explained in the previous class. Now, electrophilic substitution reaction of aniline. Right, first is as you know, aniline is highly activating group. So in case of bromination, first is the bromination in water. You take aniline and 3Br2, I mean in aqueous medium. This is ortho, para, ortho. 3HBr lost. 246. White precipitate of 2,4,6 tribromo aniline. Right, but to get the important point we are going to discuss, to get the single substituted amine, as we know that, aniline is highly activating NH2 group, which activates both ortho and para hydrogen. Hence, in order to deactivate the NH2 group, it is first treated with acetyl chloride to make them acetyl chloride ash. So it is very important, if you want to get the single product, then aniline should be deactivated. And how do you get deactivate of the aniline? By providing ethanoyl chloride or acetyl chloride. So before proceeding electrophilic substitution reactions, when you want to get the single product, it is pertinent, it is mandatory to get first acylation of aniline. So I am taking bromination here, further bromination, but not in aqueous medium. See, it is the aniline, and now I am going to procure the aniline only the single product. Now this is the Br2. In case of the acetic acid, this is the first we have to go for acylation. Cl, C double bond O, CS3 in presence of acetic acid. This H and this Cl is lost here. HCl, NH, C double bond O, CS3. Tell me anybody the name of this? N-phenyl ethanamide. This is called as N-phenyl ethanamide, or it is known as acetanilide, which is further treated with. Now it is further treated with because of we are going to take bromination. So bromination in case of the acetic acid, so this H or this Br, what is lost here? HBr lost, and then we'll get NHCO CS3 para bromo या 4-bromo aniline. It is hydrolyzed in acidic medium. This H and minus CS3 COOH NH2 or 4-bromo aniline. It is 4-bromo aniline. The single product is obtained. Therefore, it is very important to keep in mind, if you want to prepare single product, we first get it activate by providing acetyl chloride. So this is the bromination, but not this bromination in aqueous medium. It is the non-aqueous medium. In case of the little traces of the pyridine act as a poor base. Now third is the nitration. Since aniline, important question for paper, since aniline is base or basic in nature, so in a strong acidic medium, it reacts with hydrogen ion to form anilinium ion, which is meta directing in nature. Thus, in addition to ortho and para, substantial, or you can say significant amount of meta is formed. As you take aniline, I have taken the strong acidic medium, I am in concentrated nitric acid and sulfuric acid, right? These lines are very, very important. So nitric acid is going to open like this. Since it is a strong acidic medium, so you take 3 molecules, 3 OH, ortho H, meta H and para H. 3 times water is lost and it forms 3 products: aniline, orthonitроaniline, this is the meta nitroaniline, and finally it is the para nitro. 51% para is formed, 47% meta is formed, and only 2% ortho is formed. So the substantial or significant amount of meta is produced. So question comes sometimes in paper that aniline is although ortho and para directing group, but why it forms substantial or significant amount of meta is produced? Because of aniline, whenever placed in the strong acidic medium, aniline forms anilinium ion, or anilinium ion is very much meta directing in nature. As such, in addition to ortho and para, they also form meta as a significant or substantial amount. But again the question is, if you want to get the single para product, single product, then again aniline is supposed to go acylation, right? For single products, this is what it is, the aniline. Cl C double bond OCS3. In case of AlCl3, then this is the H or this is the Cl. What is lost here? HCl. NH C double bond O CH3. This is acetanilide. Now replace the H. Nitration takes place with the help of sulfuric acid. OH and H, water is lost, right? So this is the NH C double bond O CH3, and this is the para nitroacetanilide. It is para nitroacetanilide. Now hydrolysis takes place in acidic medium. This OH and this acetic acid is lost here, and then NH2, and then para nitroaniline, or we can say the major product is the 4-nitroaniline. It's all right. Last but not the least is the sulfonation of aniline. Right. Now, finally, it is the sulfonation. It is the aniline, concentrated sulfuric acid in excess of SO3, oleum. This is the HOSO3H. This H is replaced from the para point. OH and H, water is lost, and H2, lone pair of electrons, SO3 negative. So this is the SO3H. Sulfonic acid is seen here in functional group. So far as reference is concerned, this is the 1, 2, 3, and what is that? 4 amino benzene sulfonic acid, or it is called as sulfonilic acid. This is the another very important name, sulfonilic acid, a molecule which contains acidic as well as basic character, that is also considered as, what is that, amphoteric in nature. So what do they do? There is a migration of the hydrogen ion from acid to the base, because it has a lone pair of the electron, which is the negative and it is the positive. So this lone pair will be provided to the H, and H will be migrated towards the aniline. It becomes deuterion. Zwitter means two different characters belonging to the same molecule. As such, they form a crystal ion. It is the positive charge and SO3 negative. So it is called Zwitter ion. Zwitter is a German term that means two different characters belonging to the same molecule. So there is an internal migration of the hydrogen ion from acid to the base to form salt, Zwitter ion. So dear student, this is all about amines chapter are finished, and then in this chapter you go for the conversions and how to make the distinction between 1 degree and 2 degree amine, and write 2 degree and 3 degree amines as well as the nomenclature and the important carbylamine reaction, Hinsberg reagent test, Hofmann's bromamide reaction, Gabriel's phthalimide synthesis. These are very typical and important reactions. Thank you very much.